Great. Well, look, thank you. It's great to be part of this group, and just hearing you introduce everybody, it's clear how much expertise there is in this group. And it's a humbling thing to be asked to speak first. But I guess my perspective is not so much a giver of expert advice, but a receiver of expert advice. Um, I've been in government for about 17 years, working on climate change for most of the last 10. And so I've come into contact with experts on the science, also the economics and the diplomacy. And I want to share my perspective on how advice in all three of those areas could actually be different and more helpful. And I think it has very much to do with that science policy interface that you were just talking about. So, oops, let's check. Right, here we go. Science first. As you were saying, Michael, there's this changing role for science, and I like the Jane Lubchenco description of it as a new social contract for science, which is, as you were saying, focus a lot on informing the difficult decisions that society has to make, not just finding out what's interesting and new. And one of these tensions that I've come across, I put it as this tension between originality and relevance. And by relevance, what I mean is, what do we need to know to understand how bad the risks of climate change could be, and therefore how strongly we should act against them? And this was in IPCC AR5 Working Group 2. There was only one paper that asked the question, if the world gets hotter, will it get too hot for people? It was Sherwood and Huber, Limits of Human Tolerance to Heat Stress. And unfortunately, their finding didn't get reflected in the summary for policymakers because there was only one paper that had come to that conclusion, even though most people I spoke to thought that it was an underestimate, not an overestimate of the risk. Understatement, I should say. And that compared to there being 9 papers in Working Group 2 cited that were about the effects of climate change on skiing in Europe, and 13 that were about the effects of grape growing in Europe. So whether that reflected the researchers' personal interests, or more likely, I think, the search for originality in science, rather than what was really what people needed to know. So that's the first thing. The second is similar, but it's about confidence versus relevance. And you look through, you find many, many, many places throughout the IPCC reports where this choice has been made, that the scientists are more comfortable, they prioritize the communication of the information in which they have the greatest confidence, which is not the same as the information that's most relevant. Very often the high confidence stuff is actually the low impacts, whereas in terms of risk assessment, which is what it's all about from a policy point of view, we need to know about the high impacts. And this was, again, an analysis of AR5 Working Group 2, and found not only was there less information about the high-end impacts compared to the low end, but actually when you look at why, there were quite a few of these statements that said the high end hadn't been considered. It wasn't that it wasn't possible to say something about it, it was often that it hadn't been considered or the experiments hadn't been done. The third, and really the first two, are both a function of this third difference, which is the difference between prediction and risk assessment. In prediction, you ask first what is most likely to happen, and then second, you ask what are the consequences of that, and is there anything we should care about? In risk assessment, you do it the other way around. You ask first, what do we care most about? What could go wrong that would be the worst? And then you ask second, how likely is that? And in climate change terms, you have to ask how likely is that as a function of time, because the risks change over the course of time. And you look at these other fields of risk management, put these up just to illustrate the things we really care about are these non-linear thresholds of impact. You could call them socioeconomic tipping points of a bad kind. That's what we're really worried about. That's what we design our policies to respond to. It's not the central case that we care about. It's the threshold of impact, which is often somewhere at the tail of the probability distribution. And my sort of metaphor for this is the boiling frog, the proverbial frog in a slowly boiling pot of water. If he gets a prediction, then the prediction says, in 5 minutes time, you'll be 2 degrees warmer plus or minus 1 degree. And that doesn't have a very clear policy conclusion for the frog. If you get a risk assessment, the question is, what's the worst that can happen? The answer is, the worst that can happen is you get boiled alive. Then the next question is, how likely is that? And the answer is, well, not very likely in 5 minutes, but a certainty after 20 minutes. And then the policy conclusion for the frog is very clear. So in summary, science, I think, to be useful needs to, or at least the communication of science, but also not just the communication, also the research, what is produced, what is found out, needs to shift from prediction to risk assessment. Tell us what we need to know. Economics, there's a different kind of shift that's required, and it's really, Steve will talk much better about this than me, but it is a paradigm shift in the whole understanding of economics, I think. And the root of it is this concept of equilibrium, defined as a situation in which nobody has any immediate reason to change their actions so that the status quo can continue. Contrast that with, what does the IPCC say that we need to do to solve climate change? Rapid and far-reaching system transitions, unprecedented in terms of scale. That could hardly be more different. It's a situation where almost everybody has very strong reason to change their actions so that the status quo can't continue and it will be replaced with something completely different. So any economic analysis, models, theory, decision-making frameworks that's based on this founding assumption of equilibrium is just inappropriate for informing decisions about transformational change, which is what climate change is all about. And you actually find when you use that assumption to inform decisions that are in a completely different context, then you come up with unhelpful recommendations. It's not just that they're not telling us the best that we could know, they're often telling us the exact opposite of what we should be doing. One example is this idea that carbon pricing is the most efficient way to decarbonize the economy. It's very often repeated, World Bank, IMF, lots of economic institutes. There's no empirical evidence for that at all. It comes from theory and it comes from equilibrium-based theory. And so it's really not appropriate. And when you look at what has happened, this is a quote from Stefan Hallegatt, one of the top climate change economists at the World Bank. He says, look what's happened, renewable energy is cheaper than coal, people are making electric vehicles. All of this progress was actually achieved by policies focused on new investments, not with carbon taxes. And I think that's not surprising. When we stop thinking in equilibrium, start thinking in terms of complex systems and their dynamics, then actually it's really obvious. Imagine you have 5% of the market is clean tech, 95% in fossils. You have a given amount of pressure that you can apply, pressure in terms of policy or financial resources. Do you want to apply that pressure in a very concentrated way to a small part of the economy that's new and that really needs support and that has many, many reinforcing feedbacks of development and diffusion that you can strengthen? Or do you want to apply that same force over a very wide area, putting a very low amount of pressure on a very large amount of the market that is well established and only wants to push back and will probably just respond with balancing feedbacks? It's a really obvious choice which one of those is more dynamically efficient, dynamically effective. It's the investment, not the carbon pricing. So we shouldn't be surprised by what we're seeing. Second thing, I mean, regulation is just one example of the difference between market fixing and market shaping. In the equilibrium context, policy should only fix a market failure. What that really means is it should do the minimum to restore equilibrium. And this is why regulation is often seen as a negative thing. It's a distortion, it's creating a burden. In a non-static framework where we understand we're trying to change the economy, not keep it the same, the market fixing doesn't make sense anymore. It's much more about market shaping. How do we change the rules of the game so that economic evolution happens in the direction we want and at a fast pace, not a slow pace. And when you think about it that way, it's not surprising that actually regulation can accelerate innovation, accelerate cost reduction. It's exactly the opposite of what's predicted by equilibrium-based theory. And the third example, in terms of tipping points, these are two examples of the fastest transitions in the world. The fastest power sector transition in the world, which is in the UK, fastest road transport transition in the world, which is in Norway. Both of those, when you look at what's special about those compared to all the things that these countries are doing that other countries are doing as well, what is special about each of these examples is the activation of a tipping point, a threshold that was crossed that allowed one technology to outcompete another. In the cars example, it's electric vehicles versus petrol vehicles. In the power sector example, it's actually coal versus gas, but in a context where both of those were being squeezed by the growth of renewables. And so when coal started losing out to gas, coal really got killed off extremely quickly. Now, I think what's interesting is, why are those two examples so unique? Well, mostly governments haven't been told to look for the tipping points and to use tax and subsidy to cross these tipping points. Instead, they've been told that a carbon price should reflect the social cost of carbon. But the paper you were talking about, Funtowitz and Revetz, makes an extremely good case for why the social cost of carbon is a really meaningless concept. Or it can be any number that you want it to be, between 0 and infinity. It really just depends on how much you choose that you care about climate change and everything that could flow from it. So if you use that basically made up number to set your carbon price, then it's completely down to luck whether the carbon price does anything useful or not. Whereas if you look at the relative prices of particular technologies within a particular system, then it's quite easy to notice straight away what level of carbon price you need to do something useful. And of course, if you do cross a tipping point, you get a disproportionately large response in terms of system change. And so you put all these things together, and what do you find? Well, this was a report we had out at COP26 that looked at the most successful examples of low carbon transitions so far in China, India, Brazil, UK, Europe. And it found that the policies critical to those successes were generally implemented despite and not because of the predominant economic analysis and advice. And that's, I think, quite a shocking thing. And we really need to change that. What we need is more economic thinking that is based not on the assumption of equilibrium, but on the understanding of disequilibrium, the understanding of complex adaptive systems. Last part, diplomacy. This is linked to the economics. If you think that the economy is static, if you model it as static, then decarbonization will only have costs, and the diplomacy of climate change is about how you allocate those costs. So by definition, it's a negative sum game. If you think differently about the economics, you think differently about diplomacy. Actually, these are transitions that can be from one thing to something else that is better, a positive transition, as we're already seeing in the power sector. The clean power is already cheaper than coal and gas in nearly all countries in the world. And when you think about it that way, then the task is not to divide up the finite global carbon budget, even though, of course, we have to keep within the global carbon budget. The task is actually, how do you work together to accelerate up the S-curve in each sector as quickly as possible to get the zero emission technology or solution from nowhere to being 100% of the market. That's a positive sum game. And you can identify these coordination gains at each stage of the transition: faster innovation, larger economies of scale, faster cost reduction, and level playing fields where you need them, so that competition is an accelerator of the transition and not a brake on the transition. So that's a paradigm shift that needs to happen in diplomacy. To make that happen, the diplomacy has to be sector specific and not economy wide. That's because each of these sectors, they're different systems. They're different in the political economy, the industrial structure, the financial structure, the technologies we're moving from and the ones we're moving to, and the countries that matter. There are countries that absolutely dominate the market in forest risk commodities that are completely irrelevant to the market in cars or aeroplanes. So you have to split these things up and deal with each system transition on its own terms, with the right actors and the right forms, appropriate forms of collaboration for each one. And when you're doing that, I think you have to focus less on targets and more on actions. And the reason is that early on in a transition, almost nobody supports the transition. There are very few interest groups that have any reason to want it to succeed, but that changes as you go along. And this is an example. If you look at China's targets for deploying solar PV, well, their target they set in 2008 is no longer distinguishable from the x-axis because it was so small. What they actually achieved by 2020 was higher than any of the targets shown here, increased over that period. What was happening in that period when China kept changing its targets and revising them upward? Well, two things. One, China itself was taking a large share of the global market in solar panels, going from almost nothing in 2000 to about 70% of the market about 15 years later. And at the same time, massive cost reduction in solar that was making it attractive to deploy in China and economically beneficial. So there's this reinforcing feedback between the technological progress and all the economic benefits that flow from it, and then the policy interests in deploying it further. And that's what's really at work. If you focus on actions, you can activate those kind of feedbacks and make stuff happen very quickly. If you focus on targets, it's quite a weak leverage point because most countries don't have the confidence or the interest in a fast transition at the beginning of the transition. So when you think about how have we been doing diplomacy over most of the last 30 years, it's been economy-wide, it's been zero-sum or negative-sum, it's been involving all of the actors all at once, 196 countries, and it's been focused on targets more than actions. And so in all of those ways, we've made it as difficult for ourselves as we possibly could. And if you compare that to where did diplomacy ever succeed in any other fields like security or trade, or even in other environmental questions, diplomacy succeeded when we did the opposite of all of those things, when we broke up a problem into its constituent parts, worked with the minimum number of actors to achieve a critical mass towards solving that problem, and understood that interests changed over time. Start with small agreements and gradually develop them in strength and depth. Don't try and agree everything all at once with everybody in the world in a legally binding treaty at the very beginning. So we need to change all of that as well. So I just end with, these are a few reports that go into all three of those issues in a bit more depth. I'll stop there. Thank you.